March 1943. Stalag Luft III, a German prisoner of war camp built in a pine forest 100 miles southeast of Berlin, specifically designed to be impossible to escape from. The Germans had thought of everything. The barracks sat on stilts so guards could see underneath them. The soil was sandy yellow. Any tunnel dug through it would produce brightly colored spoil that would stand out immediately against the gray surface dirt. Seismograph microphones were buried around the perimeter to detect the vibration of digging. Professional escape hunters, called ferrets, roamed the compound at will, probing with metal rods, crawling under huts, listening at walls. By early 1943, the camp had already defeated 97 escape attempts. Inside one of those huts, on a cold spring morning, a South African RAF squadron leader named Roger Bushell gathered the senior officers of the X organization, the camp's secret escape committee, and outlined a plan that made every man in the room go very quiet. Not one tunnel, 3 tunnels, all dug simultaneously. And the goal was not for a handful of men to slip away quietly into the night. The goal was to put 200 men outside the wire in a single evening, creating a disruption so massive that the entire German home front would be forced to divert soldiers, police, and resources away from the actual war. But what Bushell described that morning was not primarily an escape plan. It was a manufacturing plan, a logistics operation, an industrial enterprise run entirely underground by prisoners using stolen and improvised materials beneath the noses of the most attentive prison guards in the Third Reich. This is the story of how 600 Allied prisoners built a secret factory and came within 20 feet of getting 200 men to freedom. To understand what made Stalag Luft III different from every other German POW camp, you need to understand the specific engineering decisions the Germans had made when they built it. The camp was established in March 1942 near the town of Sagen in Lower Silesia, what is now Żagań, Poland. It was designed not just as a place to hold prisoners, but as a place specifically engineered to defeat escape attempts. The Germans had studied their failures in previous camps and built every lesson learned into Stalag Luft III's design. The most critical feature was the soil. The site had been chosen precisely because its underground geology was almost uniquely hostile to tunneling. The surface layer was dark gray sand, ordinary-looking, easy to walk on. But 30 feet below the surface, the soil changed to a vivid, bright yellow, a different color so stark and unmistakable that any tunnel dug at the necessary depth would produce spoil that was impossible to hide. Dump a handful of that yellow sand anywhere near the surface, and a German ferret would spot it within minutes. The barracks themselves were raised approximately 60 centimeters off the ground on concrete stilts. This served 2 purposes. It allowed guards to crawl underneath and inspect for tunnel entrances at any time, and it eliminated the natural starting point that ground-level flooring would have provided for a downward dig. The seismograph microphones buried around the perimeter were sensitive enough, in theory, to detect the vibration of digging at depth. Any tunnel would need to go deep enough, at least 30 feet, to fall below the detection threshold of those instruments, while simultaneously being built from a starting point above ground in a building on stilts. The camp's security personnel were not amateur guards. The ferrets, German soldiers specifically assigned to escape detection, were experienced, suspicious, and unpredictable. They could enter any hut at any moment without warning. They carried metal probes, which they drove into floorboards and walls, searching for hollow spaces. They spoke English and listened at windows. They studied prisoner behavior for patterns that suggested concealment. By the time Roger Bushell arrived at Stalag Luft III in late 1942, the camp had already defeated 97 escape attempts. It had been built by people who understood exactly what Allied airmen would try to do, and it had been built to stop them. What it had not been built to stop, because nobody had ever attempted it on this scale before, was a full industrial operation running simultaneously across an entire compound. Roger Bushell was not a typical RAF officer. Born in South Africa in 1910, he had studied law at Cambridge, skied for the university team, and was by all accounts one of the most naturally charismatic and intellectually formidable men in any room he entered. He had been shot down on patrol near Calais while covering the Dunkirk evacuation in May 1940, had escaped captivity twice, and had been warned explicitly by German authorities that a further escape attempt would result in his execution. He had taken this warning as a challenge. His organizing principle for what became the X organization was simple and radical. Treat the entire escape effort not as a collection of individual attempts, but as a single coordinated industrial enterprise. Every prisoner in the compound would have a specific job. Every department would have a head. Every department head would report to Bushell, Big X, through a cell structure that ensured no individual prisoner knew enough about the whole operation to compromise it if captured and interrogated. The departments Bushell established reveal just how comprehensively he had thought through the problem. The Tunnel Engineering Department was led by Wally Flutie, a Canadian pilot who, before the war, had worked as a hard rock miner in the northern gold mines of northern Ontario. Flutie had spent years doing the physically demanding work of underground excavation, shoveling rock and debris from active mine faces deep below the surface. He understood soil behavior, structural integrity, ventilation, and the mechanics of underground construction at a practical level that no textbook could have provided. He designed all 3 tunnels and oversaw their construction personally, crawling through them to inspect progress and solve structural problems as they emerged. The forgery department, internally named Dean and Dawson after a well-known British travel agency, was led by Flight Lieutenant Tim Wallen. His team of forgers produced every document an escaper would need once outside the wire: German identity cards, travel passes, military leave papers, civilian work permits. Many of these documents took up to a month to create. The forgers obtained real German documents by bribing or stealing from guards, then reproduced them by hand with extraordinary precision. At its peak, the Dean and Dawson operation was producing forged documents for 200 planned escapers simultaneously. The mapping department was led by Flight Lieutenant Des Plunkett. His team produced hand-drawn copies of railway maps, road maps, and regional maps covering every possible escape route from Sagan to neutral territory, Sweden, Spain, and Switzerland. To reproduce maps at scale, Plunkett built a mimeograph, a hand-operated duplicating machine, from materials he had collected within the camp. The tailoring department was run by Tommy Guest. His team took German military uniforms, RAF flying suits, and ordinary prisoner clothing, blankets dyed with improvised colorings extracted from boot polish and other materials, and converted them into credible civilian clothes, business suits, and workmen's outfits. The craftsmanship was precise enough that several escapers passed visual inspection by German police on railway platforms. The manufacturing department, led by a Rhodesian officer named Johnny Travis, produced the physical tools the escape required. Compasses were made from fragments of broken Bakelite gramophone records, melted and reshaped, with needles fashioned from slivers of magnetized razor blades. Each compass was stamped on its underside with the legend, "Made in Stalag Luft III, patent pending."
The department also produced digging tools, lamps, and every piece of hardware the tunnel engineering team required. The security department, led by an American officer, Lieutenant Colonel Albert Clark, designated Big S, coordinated a network of prisoner lookouts whose job was to track every German guard and ferret in the compound at every moment during working hours. These watchers, called stooges, used a complex system of signals to warn the underground departments the instant a ferret entered a hut or changed direction. The system was refined to the point where the Dean and Dawson forgers could conceal an entire working session and restore a room to apparent normality in under 60 seconds. More than 600 prisoners were directly involved in supporting the operation. Most of them would never go near a tunnel.
The 3 tunnels were named Tom, Dick, and Harry, partly for simplicity, partly because using mundane English names in conversation attracted less suspicion than code words. All 3 began simultaneously in the spring of 1943, each starting from a different hut in the North Compound, each heading in a different direction toward the forest outside the wire. The engineering problem Floody faced was severe. The tunnels needed to be 30 feet deep to avoid both the seismograph microphones and the detection probes the ferrets used on the ground. They needed to be structurally sound enough to support thousands of crawling bodies over months of use. They needed ventilation systems that could deliver breathable air to a working face potentially 300 feet from the entrance shaft. They needed lighting. They needed a transport system to move excavated sand back to the entrance without requiring diggers to carry it by hand through 300 feet of narrow tunnel. And all of this needed to be built without power tools, without structural steel, without professional building materials of any kind. The solutions Floody's team developed were elegant under the circumstances. The tunnel cross-section was fixed at exactly 2 feet square, the precise width of a standard wooden bedboard. The shoring was built from bedboards, removed from prisoners' bunks and replaced with improvised substitutes that left men sleeping on the barest minimum of support. Across all 3 tunnels, more than 4,000 bedboards were eventually stripped for shoring material. Prisoners who slept on the remaining boards, sometimes as few as 2 or 3 per bunk, adapted without complaint. The ventilation system was built from powdered milk tins provided by the Red Cross, specifically the cylindrical cans from Red Cross food parcels. Floody's team pierced holes in each tin and joined them end to end, constructing a continuous pipe that ran the length of the tunnel beneath the floor. A bellows pump at the entrance, built from a kit bag frame, hockey sticks, and ping-pong paddles, forced fresh air down the pipe to the working face. The system was crude, but functional enough to allow continuous digging shifts without the oxygen depletion that had defeated previous tunnel attempts. The lighting system used wire tapped illegally but successfully from the camp's own electrical supply. A string of small bulbs ran the length of each tunnel, powered by the camp electricity and providing just enough light to work by. When the Germans conducted electrical inspections, the connections were hidden behind false panels. The transport system was a miniature railway. Wooden trolleys, flat platforms mounted on wooden wheels, ran on rails constructed from bedboard timber. Diggers at the working face loaded excavated sand onto the trolley. A man at the junction point near the entrance pulled it back by rope. The system was efficient enough that a single working shift could move several hundred pounds of sand from the working face to the entrance shaft in an hour. The sand disposal problem was the most visible and dangerous challenge of the entire operation. The bright yellow excavated sand, so different in color from the gray surface soil, could not be dumped anywhere without immediately revealing that tunneling was underway. The solution was the penguins. More than 200 prisoners were designated as sand dispersal specialists. Each wore specially made bags sewn from long underwear, suspended from cords around their necks inside their trouser legs. Filled with yellow sand, a penguin would walk out into the compound, appearing bulky and slightly stiff-legged, release the sand gradually through the bag's open bottom while strolling, gardening, or standing in conversation, and return to collect the next load. The release cord was operated by a string running up through the pocket. Over the months of construction, this system moved an estimated 166 tons of yellow sand into the camp's surface areas without the Germans finding a tunnel. Large quantities were also hidden under the theater, a building that, uniquely in the camp, had a solid concrete foundation rather than the standard stilts. The prisoners had contributed their labor to building the theater on the understanding it would not be used for escape purposes. Internal legal advice concluded that this restriction applied to the building process, not the completed structure. The sand went under the stage. Tunnel Tom was discovered by German ferrets in September 1943, the 98th tunnel found in the camp's history. Its loss was a significant setback, but not a catastrophic one. The operation consolidated onto Harry.
By March 1944, Tunnel Harry was complete. It ran 336 feet from its entrance beneath a stove in Hut 104 to a point that the surveyors had calculated would emerge well inside the tree line of the forest beyond the wire. The night of March 24th was chosen because it was moonless. The next moonless night would not come for another month, and Bushell judged the operation could not wait that long. 200 prisoners had been assigned numbers determining their order of exit. The first 30 were the strongest escape candidates, German speakers with complete document sets, civilian clothing, and train tickets for the first legs of their routes. The remainder would follow in order, harder case escapers who would have to rely on speed and luck once outside. The first man through, Flight Lieutenant Johnny Bull, pushed open the exit shaft and discovered the operation's final engineering failure. The tunnel had stopped 20 feet short of the tree line. The exit hole was in open ground, visible from the guard patrol path. The choice was made to continue. A rope was rigged from the tunnel exit to the nearest trees. A man at the rope's end would tug twice when the guard had passed, signaling the next escaper to run. It added minutes between each exit. It reduced the number who could get out before dawn. By 4:45 in the morning, a German guard stumbled over the exit hole. A shot was fired. The tunnel was over. 76 men had escaped. Of those, 73 were recaptured within 2 weeks. 3 made it to safety. 2 Norwegians who reached Sweden by ship, and a Dutchman who traveled through France and Spain to Gibraltar. Adolf Hitler, in a fury, ordered the execution of all 76. Hermann Göring persuaded him to reduce the number. 50 were selected. They were driven to remote locations across Germany and murdered by the Gestapo, shot in the back of the head, and recorded officially as having been killed while attempting to escape. Roger Bushell was shot on the Autobahn outside Ramstein on March 29, 1944. He was 33 years old.
The standard measure of the Great Escape's success is the 3 men who reached neutral territory. By that measure, it failed spectacularly. 76 men escaped and 50 were murdered. But Bushell's stated objective was never primarily to get men home. His stated objective was to cause maximum disruption to the German war effort. By that measure, the results were significant. The German response involved police, Gestapo, army units, and home guard forces mobilized across the country in one of the largest domestic manhunts of the war, diverting real resources from military operations at a critical moment when Germany was fighting on 2 fronts simultaneously. Roadblocks were established across the country, border crossings were locked down, the search pulled experienced personnel away from duties that mattered directly to the German war effort. The deeper achievement was the manufacturing operation itself.
The X organization had, over the course of roughly a year, produced 250 complete sets of forged travel documents, 50 civilian outfits, 90 hand-drawn maps covering dozens of escape routes, 30 compasses, and enough tools and equipment to build 336 feet of engineered underground tunnel, all of it manufactured inside a prison camp, beneath the noses of professional escape hunters, using nothing but Red Cross tins, bedboards, gramophone records, stolen wire, and the professional expertise of 600 captured airmen who refused to consider themselves out of the war. The Germans found Tom, they never found Dick, they never found Harry until the night it was used. The tunnel entrances were so precisely constructed that even when German officers were told exactly which hut to search and stood directly above the trap door, they could not find it.
The Great Escape is remembered primarily as a story of courage, and it was. 50 men were murdered for it. That fact never loses its weight. But underneath the courage was something that deserves equal recognition. One of the most sophisticated, improvised manufacturing operations ever assembled under constraint. The X organization solved every engineering problem the Germans had designed into Stalag Luft III. The seismograph microphones were defeated by going deep enough. The visible sand was defeated by the penguins. The stilt-raised huts were defeated by going through the concrete chimney foundations. The ferrets were defeated by 60 seconds of concealment and a stooge network that tracked their movements minute by minute across the entire compound. Every solution was built from first principles, from available materials, by men whose professional skills had been in flying aircraft, not in forgery, tunnel engineering, tailoring, or map-making. Wally Flutie had been a miner. Tim Wallen had been a commercial artist. Des Plunkett had been an engineer. Johnny Travis had been a businessman. In captivity, each became exactly what the operation needed. The lesson the X organization embodied, that a sufficiently motivated group with the right organizational structure can solve almost any engineering problem, regardless of their available resources, has been studied in business schools, military academies, and operations research programs for decades. 600 men, 3 tunnels, 166 tons of sand, 50 murdered, 3 free, and a secret factory beneath a pine forest in Poland that the Germans never fully understood until the war was already lost. If that kind of story is what keeps you here, subscribe and stay ready, because every script on this channel starts with the same question, not what happened, but how they solved it.